This is the prerequisite worksheet for section 3.7, polynomial and rational inequalities. So we are going to begin with objective 1. There are 3 objectives on this worksheet, and objective 1 is interval notation. So we're going to first write the graph. X is greater than or equal, so we need a solid point, then 6. And we want all of the values greater. So here our left boundary is 6, our right boundary is infinity. Since 6 is included because of the equals, we use a bracket, and we always use parentheses for interval notation. Okay, moving on to number 2. We want all of the x values between -2, but we don't want to include -2, and 7, and we do want to include -2. So x is between those two values. So we want -2 to 7. We want to include 7, but we don't want to include -2. Okay, taking a look at objective 2, here we are going to be solving inequalities, and we will write our solution set in interval notation. So let's begin with number 3. Here we will subtract 2q from both sides, and we will end up with q minus 7 is greater than 3. We can add 7 to both sides, and we have q is greater than 10. And make this just a tad bit smaller so we can wrap this up. And we end up with q is greater than 10. So making a number line, we want 10 and greater. We do not want to include 10, so our solution is 10 to infinity. Okay, let's go on to number 4, and here we are going to subtract 9 from both sides, and we have 7x on the right side and a -21 on the left. Now we will divide both sides by 7, and we have x is less than -3. So let's go ahead and read that backwards. X is less than -3. So we have a number line, open point at -3, everything less. So our solution set is -infinity to -3 with open parentheses. Moving on to number 5, let's distribute that 6 first. And let's combine our like terms on the left side. So 8 plus 18 is 26. Here we can now add 4x to both sides, and we have a -2x, and we still have that 26 is greater than 12. We can subtract 26, and we have a -2x is greater than -14. And now we will divide both sides by a -2. Now keep in mind, when we multiply or divide by a negative, we do have to reverse that sign. So now we have x is less than a +7. So our number line, we have 7, and we want everything less. Our left bound is -infinity. Our right bound is 7, and we do not want to include 7. Taking a look at number 6, we have to distribute the 3 distribute the half. And now let's combine like terms. Here we have a 3 minus a 2. So we have 3x plus 1 is less than or equal to 2x minus 4. We'll go ahead and subtract 2x from both sides. And we have x plus 1 is less than or equal to negative 4. See if I can just bring this up. Well, I'll just leave it about like that. Okay, now let's go ahead and subtract 1. And as you can see, we now have x is less than or equal to negative 5. And on our number line, we actually have negative 5 with a close point, and we want everything less. So our solution set is negative infinity to negative 5, and we will include that point, negative 5. Taking a look at number 7, we have an or, so we will include both answers. Let's go ahead and add 7 to both sides, and here we have 3w is greater than or equal to 24, and then we will divide both sides by 3. And where's that 3? And we will have w is greater than or equal to 8. Now, we have w is greater than or equal to 8, or w is less than 1. So taking a look at the number line, we want all of the x values less than 1 or greater than or equal to 8. So here we have two intervals, negative infinity to 1, union, and now we will include 8 in the set and go all the way to infinity with our values. Okay, let's take a look at our last objective, which is objective number 3. And here we are going to be adding rational expressions together. Keep in mind, we do need common denominators before adding. Okay, so taking a look at number 8, our denominators are the same, so we can say that this is 1 plus 7 over 3, or we have 8/3. So since the denominators are the same, we can add the numerator together. Taking a look at number 9, you can see that we have 2a plus 4 all over a plus 2. And we can factor a 2 out of the numerator. And as you can see, that a plus 2 will cancel that factor, and we come up with 2. Taking a look at number 10, our denominators are the same, so we will add our numerator together over that single denominator of n plus 5. Now let's go ahead and factor that numerator, and as you can see, the n plus 5 factors cancel, and we end up with just n plus 2. Moving on to number 11, as you can see, we do not have common denominators, and the LCD of 4 and 11 is 44. So we want our denominators to each be 44. So we will multiply the numerator and denominator of our first term by 4 over 4 and our second term by 11 over 11. That way we will have denominators, but we have both terms to be 44. So multiplying the numerators and the denominators together. So as you can see, our denominators are now the same. So we have 32 plus 11y all over 44. Okay, let's see what we have in number 12. In number 12, our denominators are not the same. So again, we will need to have a least common denominator, and that LCD is going to be m plus 1 multiplied by 2m plus 5. So we will need both denominators to have that as the new denominator. Okay? So let's go ahead and see. We'll multiply 2m plus 5 divided by 2m plus 5. Probably don't need these parentheses. And we're going to do the same for this second term, 4 over 2m plus 5. And going ahead and multiplying that numerator and denominator by m plus 1. So now you can see we have m minus 1 times 2m plus 5 plus 4 times m plus 1 all over m plus 1 multiplied by 2m plus 5. Now we have quite a bit of algebra to do. I do want you to keep in mind to go ahead and leave the denominator alone. Leave the denominator factored for now. So let's multiply our numerator together. We will have, and we'll go ahead and FOIL that, 2m squared minus 5, 2m squared plus 5m minus 2m minus 5 plus 4m plus 4. And let's go ahead and simplify that numerator first. So here you can see we have 5m minus 2m plus 4m. So that's going to be 7m, so 2m squared plus 7m, and now we have a negative 1, all divided by m plus 1 multiplied by 2m plus 5. And that is our solution. That is both of those rational expressions added together. Okay. If I can move that a little bit. And let's go ahead and take a look at number 13. As you can see, the denominator of 7b is just 1. So our LCD is a minus 5. So we will need to multiply 7b by a minus 5 over a minus 5. And that gives us 6 plus 7b times a minus 5 all over a minus 5. And maybe I'll write those separately first. 6 over a minus 5 plus 7b times a minus 5 over a minus 5. So now we have 6 plus 7ab minus 35b all over a minus 5. Looking at our next problem, we see that we have two terms, and both of these terms have 1 as the denominator. So both of those terms will have to have an LCD of a minus 1. I'll go ahead and write that over here for this one is a minus 5. And here our LCD will have to be a minus 1. So our first term, a over 1, will need a minus 1, a minus 1. Plus 1 will need a minus 1 divided by a minus 1. Plus 1 over a minus 1. So as you can see, we have a times a minus 1 all over a minus 1 plus a minus 1 over a minus 1 plus 1 over a minus 1. So we have a squared minus a plus a minus 1 plus 1 all over a minus 1. And as you can see, our a's cancel, and so do our 1's, and we end up with a squared over a minus 1. And that concludes this worksheet.